just kind of get a front view. So you might want to look at the toaster. You might want to see what's happening up there and really think about what types of energy conversions are taking place in a toaster oven. Write what it starts as. Write what it turns into.
Mr. Feeding, can I move?
Sure. Just don't get in the way of the camera because we can't have any kids' faces on the internet.
Yes, that's way not. Will it explode? Yeah, if you grab that's gonna explode.
All right, back away from the toaster, please. Everybody return to their seats. That should have been enough time to look.
Tater tots.
Okay? Now, raise your hand if you can tell me what type of energy we start with here in a toaster oven. What type of energy are we starting with? Ray.
I said electrical since it's plugged in.
Okay, yeah, it's electrical. We have to have it plugged in. So you can start with electrical energy. Okay? If it's not plugged in, is the toaster going to work?
No.
No, it's not. So we really do need that electrical energy. What does the toaster turn that electrical energy into? Amani. Thermal energy. So a little bit of heat in the form of, so we'll call that thermal energy. That's our scientific description of heat. And anything else? Is it just electrical to thermal?
No.
Abby?
Light.
Light energy. Why do you say light?
Because there's the light in there, and it's the kind of light that can help.
Yeah. If you were able to see from your desk or you came up and looked, you can see that that bar in there is glowing orange. Okay? So we've got some light energy. Anything else? Brock?
I'm trying to capture some sound.
Sound. If you're really quiet, you can hear some sound energy as well. Anything else? Bella? No? Cam?
Heat energy?
Well, that's what thermal energy is.
Oh, sorry.
So we've got it. So what a toaster does, it takes electrical energy, it turns it into thermal and light and sound. Okay? Now, we're going to use that to our advantage today because we're going to make some tots. Who likes tots? Tater tots. Okay?
Are we gonna eat them?
They are not gluten-free, so if you're gluten-free, I apologize. We're going to make some tots. Now be patient. We're going to do a bunch of other demos. These things take about 20 minutes to cook, so we're going to have to let them go. Okay? Sit down.
Ooh, I can smell it.
All right. Next demo. Next demo, we're going to call light bulb. Pretty simple. Light bulb. All right? So, here we go. Your regular old incandescent light bulb. Think about what does the energy start as? What does it turn into when I turn it on? Did you do your homework last night? Did you do your homework? What were you doing last night?
They need to have sunglasses at school.
Okay.
Johnny.
Okay, quiet down. So, think about it. Light bulb, what type of energy does it start as? What does it turn into? I'm going to give you about 30 more seconds. Okay, who can tell me what type of energy we're starting with here? Izzy.
Electrical?
Electrical. Yes, it has to be plugged in. If it's not plugged in, it's not going to do anything. All right, so we start with electrical. So write that down on your sheet, electrical. Hopefully you were able to figure that out. If you can't figure out that a light bulb works with electricity, I don't know if I can help you.
Marco, you can move if I'm in your way.
Hey.
Okay, so we start with electrical energy. What does it turn into? Kieran?
Heat.
Heat. Yeah, Brock came up, put his hand over there. He was like, oh yeah, I can feel some thermal energy. There's some heat generated there.
But first the light.
Okay?
Then thermal.
But it takes the light okay, and thermal. Okay? So electrical energy into light and thermal. Now, I'm going to turn this off for a second, and I want you to think about something. I think I'm going to turn it off.
You broke it.
The switch is not really working here.
Just unplug it. Smash
Oh.
it. Just unplug it.
You walk around?
I dare you.
Hey, that's not really appropriate or nice. Knock it off, or you'll be out of here. Now that's on video. How do you feel about that? Pretty ashamed? I would. All right. So light bulb. Okay. This is an old-fashioned incandescent light bulb. All right. A lot of what these incandescent light bulbs do is they turn a lot of that electricity to heat. Okay. When you turn on a light bulb at your house, do you turn it on to make your house warm?
No.
No. You turn it on to provide light. And so one of the unfortunate things about incandescent light bulbs is that they convert a lot of that electrical energy into heat. And that's not something that we really want. Okay? So we'd say that these things are not very efficient. Many of you probably don't have light bulbs like this in your house at all anymore. You probably have, I need you to raise your hand when you want to say something. You probably have compact fluorescents, which are those little spirally looking ones. Raise your hand if you've got those in your house. Okay? The reason we use those is because they're more efficient. They actually turn more of the electrical energy into light, and they have less heat involved. Okay? So that they're using the electricity for what we want it to do, which is create light, not to generate heat. They still get pretty warm, but not as hot as these things. The newer, fancier version of these are things that are called LEDs, or light-emitting diodes. And they produce almost no heat, no thermal energy, just a little bit. So they're turning all of that electrical energy into light. They last a lot longer. They're way more efficient because they don't produce a lot of heat, but they are really expensive. So right now, not a lot of people have the LED lights throughout their house. You might have an LED headlamp or flashlight or something, but because these convert less, or these convert so much energy to heat, we are trying not to use them anymore. Rock. In the theaters, are typically those ones along the aisles. Yeah. Those are LEDs. Okay, pretty good?
Yeah.
All right, next demo. It's called flashlight. Flashlight. Okay, so I've got a little flashlight. It's actually an LED flashlight. All right, so turn it on, turn it off. Think about, where does the energy start? What does it get converted into? This one's a little trickier.
Does it require batteries?
It does require batteries, so I will unscrew it. I'll show you guys. Inside of it there are 3, I think they're AAA batteries.
They're also kind of like kinetic. 3 of those?
Yeah.
There's lava.
So think about it, write it down. Check on these tots for a second.
Are they like red tots or?
What's a bread tot?
They're bread.
No, they're tater tots.
Mashed potatoes.
Oh, yeah, right. I knew
Never
that.
heard of a bread tot.
Red tots go Sonic and get like just make them hash browns. Hash browns are like.
I don't like hash browns. I don't like hash browns. I love hash browns.
That's what I have to recipe.
I
Put like maybe kinetic.
How's Sandra feeling?
I'm gonna flick you.
Okay, so what do we start with in a flashlight? What type of energy do we start with? This is probably the hardest part of this whole deal. What do we start with? Johnny.
Well, actually, technically, you actually have to use
Oh, wow.
That's what I was
Now
saying,
that's
like,
going way back. So I need to put some energy in, otherwise it's not going to turn on. Where does that energy come from?
Your finger.
Food.
Potential.
The switch thing.
Your muscle. Your muscles.
The button.
My muscles. What do I need to make my muscles move? Food, chemical energy. So we could say that it starts with chemical energy from the food that I ate, gives me enough energy to press the button, turn the light on.
Don't let me get this straight. Don't eat.
No, I didn't call you. Okay? So, if you don't eat food, you can't turn it on. Because you won't have any energy, you'd be dead. But let's disregard that, because like I said, remember I said some of you are going to be able to think farther back and think more about the energy? Let's just take the flashlight itself. Okay? What does the flashlight need in order for it to turn on? Kieran.
Batteries.
A battery. So what type of energy, what form of energy is a battery? Abraham? Potential. Yeah, there's some energy stored up in it. So what form of potential energy is it? Ismenia? Chemical energy. So in a flashlight, we have to start with chemical energy. There's a chemical reaction that's taking place in the battery. What next? What does that chemical reaction do? Marco?
It produces light.
Before it produces light, it's got to do something else. Izzy?
I mean electrical.
Electrical. So the flashlight takes that chemical energy from the battery, turns it into electrical energy. And then what do we get?
Light.
Light.
But I have a question for one of them.
Light.
Is there?
And some heat. Since this is an LED flashlight, it's not very warm. Kieran felt it. It's a little bit warmer now. It's been on for a bit. But it doesn't get really, really hot.
So is it like thermal?
So it's got some thermal. Okay? So when I wrote heat up there, I should have written thermal. My bad. Okay? So flashlight takes chemical energy from the battery, turns it into electrical, which turns it into light and thermal. Pretty cool. All right, now this one's going to get even trickier. Progressively getting harder on these demos, I think. I've got something up here that is called a forever flashlight. So think about now, where does the energy start in order for us to get this to light up? And what does it turn into? So think about it right now. Start writing.
Wait, forever light?
We can call this forever flashlight.
Does it have some kind of? Like a generator.
So tell me, what does it start as? What does it turn into? Does not require any batteries. That's why it's called a forever flashlight. Can never run out of batteries.
We're not getting the kids in.
No, yeah, it is pretty hard.
Yeah. Pretty much went to Blackbird.
Cool. There's only one more. It's a switch. All right. Who thinks they've got it? What do we start with in our forever flashlight? What do I start with? I want to hear from some new people. Gray?
Like Ronnie said before, you're not food in your body because you have to
Yeah, I need some energy for my body to be able to squeeze this. If I've got no energy left in my body, can I squeeze it?
Nope.
No, so what type of energy is that?
Chemical.
Chemical or potential. So we'll say it starts with chemical energy from my body.
Can I do potential?
Or potential energy from my body. What happens next? I take that chemical energy, I turn it into something else. Abby?
Kinetic energy.
Yeah, kinetic. I gotta move this handle. And I'm gonna pass it around for everybody to try in just a second. Chemical to kinetic. Okay, because I gotta get that handle moving. Now what happens after I turn it to kinetic? What do we get? Izzy?
You got light energy.
You get some light. Okay. Even before we get light, we gotta get something else. Ooh, hold on a second. Let me check on our tots. That was a pleasant sound. I don't think they're done yet. So, we got kinetic energy, we're moving the handle. What does it turn it into? Svenja. It's going to have some thermal because we're moving. Okay? What else? Imani? Sound. You guys can hear it. It's pretty loud, kind of annoying. What else? Hear it?
Well, I'm not gonna say that, but is it just like the toy? Does it have a gear? Coil in it?
Generator.
It has some gears in it, a little generator. So what is that generator doing?
Making energy.
Using energy like electrical energy.
Brock got it. It turns it into electricity. Okay? Sorry, Bella. So we got that thermal and that sound, and it's converting it into electrical. And then what happens after we get the electrical energy? We get light.
And I want a little bit of this.
Okay?
That's a lot of energy.
It's a lot of energy for something simple as getting a flashlight to go.
But you don't run out of batteries.
You can never run out of batteries in this one. It's kind of nice. All right, last one. Okay? You can call this one. I'm running out of room. I'm going to have to write on the top of the board here. You can call this one the mystery. All right? Because I don't want to give it away with what it really is. All right, so I'm going to turn the lights off for this one.
Oh no.
All the way off. All right? And here's what I'm going to show you. I've got some chemicals. I've got a clear liquid. I don't know if you guys can see. Can you guys see that back there? Arwen, can you see that?
Yes.
And I've got a beaker with kind of a yellowish liquid in it. Ew. Someone in my last class said, oh, it looks like Gatorade. I said, don't drink it. It's not Gatorade. All right? So, this is what we're starting with. You probably already have an idea of what type of energy this starts with.
Chemical.
Here we go. I'm hoping we're getting this on film. I'm going to mix these chemicals together. You sit down. You'll be able to see fine.
Oh my god. That is awesome.
Okay, so we've got a starting form. What do we turn it into?
It looks like the exit sign.
Go ahead and write about it in your notebook.
Yeah.
I think we can probably be done filming.
Sticks.